Hello, 10th class chemistry, acids and bases, lecture 2. How do acids and bases react with metals? Till this point, we were discussing in last class, right? See, activity 2.3 caution. This activity needs the teacher's assistance. I am here, teacher, so don't worry, we are not doing any lab here. See, the apparatus as shown in figure 2.1, take about 5 ml of dilute sulfuric acid in a test tube and a few pieces of zinc granules to it. See, this is test tube and hydrochloric sulfuric acid and zinc granules are added here. So, this part you are seeing. What do you observe on the surface of zinc granules? From here, hydrogen gas is evolved. Okay. Pass the gas being evolved through the soap solution. So this is the solution, soap solution. Okay, now from this the gas is coming. Ding 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 ding. This is coming like this. And all these bubbles are hydrogen gas bubbles. So what's there? Why are bubbles formed in the soap solution? Because of hydrogen gas. Take a burning candle near the gas filled bubble and what do you observe? Repeat the activity with some more acids like HCl, HNO3 and CH3COH. Are the observations in all the cases the same or different? Same. See what happened here? This is all apparatus, stand. Okay. Test tube, dilute sulfuric acid, zinc granules are added here. And between zinc and dilute sulfuric acid, the reaction will be like this to form zinc sulfate and hydrogen gas. So zinc sulfate is formed in this solution and hydrogen gas is coming out, and that hydrogen gas is sent into the soap solution. Along with this soap solution, this hydrogen, because of this soap solution there will be bubbles, soap bubbles filled with hydrogen. And here when you are keeping the candle, burning of hydrogen gas with a pop sound. This is all apparatus. And the process very simple. Note that the metal in the above reactions displaces hydrogen atoms from the acids as hydrogen gas and forms a compound called salt. Thus, the reaction of metal with an acid can be summarized as acid plus metal is called salt plus hydrogen gas. Fine. So, metals means bases, you can say. Note that the metal in the above reaction displaces hydrogen atoms from the acids, so it behaves like a base. Acid is an acid, metal is a base, so you are getting their salt and hydrogen gas. Can you now write the equations for the reactions you have observed? Okay, now I have mentioned already zinc and H2SO4. If you want to write zinc plus 2HCl, ZnCl2 plus H2. Place a few pieces of granulated zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the contents of the test tube. Repeat the rest of the steps in activity 2.3 and record your observation. Same thing happens because zinc reacts with even sodium hydroxide to form sodium zincate and hydrogen gas is coming out. This is very interesting because we said zinc is a metal, metal is base, sodium hydroxide is also a base, so base should not react with base, right? So generally what happens is metals are bases, but not all. Few metals like aluminium, zinc, they are having semi-metallic nature, or you say metalloid nature. That means they can react with acids as well as bases. Aluminium, zinc type of metals, they react with acids as well as bases. See, that is mentioned here. You find again the hydrogen gas is formed in the reaction. However, such reactions are not possible with all metals. Don't expect with sodium, don't expect with potassium, but you can expect with aluminum and zinc type of metals. Okay, so few metals they react with even bases to release hydrogen gas. Not all metals, few metals only, but all metals they react with acids to liberate hydrogen gas. Most of the metals. Coming to how do metal carbonates and metal hydrogen carbonates react with acids? See this apparatus, similar type, na? So what we are using is hydrochloric acid and sodium carbonate. What happens here? Na2CO3 is base, hydrochloric acid is acid. So the reaction is 2NaCl plus H2O plus CO2. So CO2 gas is released from this. And that CO2 gas is passed into calcium hydroxide solution. The CO2 formed here is acid in nature. When this is passed through calcium hydroxide, it forms calcium carbonate. Okay, now CaCO3 plus H2. But you must be very careful to note this. This is a precipitation. White precipitate is formed. But by mistake, if you are passing carbon dioxide for long time, then it will be like calcium bicarbonate, which is completely soluble. See, first hydrochloric acid is reacting with sodium carbonate and releasing carbon dioxide. To test the carbon dioxide, we are passing the carbon dioxide into calcium hydroxide solution, so that you are getting there a calcium carbonate white precipitate. But if carbon dioxide you are passing for long time, this white precipitate will disappear. So you must be very careful. If you are passing long time carbon dioxide and you are expecting a precipitate, no, already precipitate formed and that has gone. So you must be careful with it. So let us see what is mentioned here. Take two test tubes, label them as A and B. Take about 0.5 grams of sodium carbonate in a test tube and 0.5 grams of sodium hydrogen carbonate, NaHCO3 in test tube. Both are bases. Very comfortably they react with acid. Add about 2 ml of dilute HCl in both the test tubes. What do you observe? Pass the gas produced in each case through lime water calcium hydroxide solution as shown in figure 2.2. Okay, so that figure already we have seen. The reactions occurring in the above activity are written as C. Na2CO3 reacts with HCl to form NaCl, H2O and CO2. NaHCO3, HCl, NaCl, H2O, CO2. The only difference is here Na2CO3 is reacting with 2 moles of HCl, whereas NaHCO3 is reacting with 1 mole of HCl. That is the only difference. Remaining all are same. And whatever the carbon dioxide is passed here, that you are passing through calcium hydroxide solution to form calcium carbonate, a white precipitate plus water. But you must be careful, because on passing excess of carbon dioxide, the following reaction takes place. CaCO3 plus H2O plus CO2, calcium bicarbonate soluble in water. Generally, we use a word na hard water, soft water. Hard water is because of such kind of salts. Magnesium bicarbonate, calcium bicarbonate. They are responsible for the hardness of water. How do you identify hard water? Very simple. When you go for face wash, okay na, if the soap, whatever the soap you are applying on your face, if it goes immediately, the water is hard water. If the soap is continuously giving you rinse, okay na, continuously giving you foam, that means the water is good water. Okay, so hard water is because of such kind of salts. Just some idea. Limestone, chalk and marble are different forms of calcium carbonate, CaCO3. Limestone, chalk or marble. Marble means immediately it should come into your mind, right? Taj Mahal, right? Chalk piece. In our classroom we can see chalk piece. Okay, if you are using whiteboard marker, then you can't. But बचपन में तो आप देखे ही होंगे definitely. All metal carbonates and hydrogen carbonates react with acids to give corresponding salt, carbon dioxide and water. The reaction can be summarized as metal carbonates, metal hydrogen carbonates plus acid gives rise to salt, carbon dioxide and water. Whatever we have taken, that whatever we have observed till now, we have written here. Coming to how do acids and bases react with each other. Very simple. Acid plus base is equal to salt and water. This is neutralization reaction. Very well known to us. Na? So here is an activity. We'll see this activity. What he is doing is, first he is taking sodium hydroxide. Only sodium hydroxide is there. To this some phenolphthalein is added. We know phenolphthalein, when you are adding, this turns into pink color. And to this, drop by drop, we are adding HCl solution. And when adding HCl solution, slowly it is getting neutralized. So pink color slightly disappears finally. Okay, na? Pink color, starting full pink color will be there. The pink color will be slowly decolorizing. And finally a colorless solution forms. When a colorless solution is formed, it means the sodium hydroxide is completely neutralized by HCl to form NaCl and water. When there is no sodium hydroxide, there is no excess HCl, the solution will become colorless. Now, what he has mentioned in this table, in this blue color paragraph is, finally, again, if you are adding NaOH, what happens? What happens again? Pink color will come. Okay. Chalo, let us see what he has given here. Take about 2 milliliter of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. Right? What is the color of the solution? Pink. Add dilute HCl solution to the above solution drop by drop. Pink color disappears slowly. Is there any color change for the reaction mixture? Yes. Why did the color of phenolphthalein change after the addition of an acid? Because the base quantity is gradually decreasing, base is reacting with acid and salt is getting formed. Now add a few drops of NaOH to the above mixture. Again, yes, when you are adding NaOH again, then definitely phenolphthalein will come. Does the pink color of the phenolphthalein reappear? Definitely reappears. Why do you think this has happened? Because again, base. In the above activity, we have observed that the effect of base is nullified by an acid and vice versa. The reaction taking place is written as NaOH plus HCl gives us to NaCl plus water. This reaction is, I think all of you know. The reaction between an acid and a base to give a salt and water is known as a neutralization reaction. In general, a neutralization reaction can be written as base plus acid gives a salt plus water. If you want a few more examples, H2SO4 plus 2 NaOH, Na2SO4 plus 2H2. Fine? Fantastic. If you want some other, calcium hydroxide, it is a base plus 2HCl, it is an acid, CaCl2 plus 2H2. Okay. Outside people will be dragging, don't worry about them. Okay, just focus. Reaction of metallic oxides with acids. Metallic oxides are basic in general. Non-metal oxides are acidic in general. Metallic oxide, take a small amount of copper oxide in a beaker. Copper oxide we are taking here CuO in a beaker and dilute hydrochloric acid is added here 2HCl. The reaction is CuCl2 plus H2O. It is base, it is acid, it is salt, this is water. So it is again neutralization. Again, a metallic oxide plus acid gives rise to salt and water. Note the color of the solution. What has happened to the copper oxide? You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper 2 chloride. Blue-green solution. The general reaction between the metal oxide and acid can be written as I have mentioned you the example also CuO plus 2HCl gives CuCl2 plus H2. Now write and balance the equation for the above reaction. Already we have done. Since metallic oxides react with acids to give salts and water, you can say metallic oxides are basic in nature. Similar to the reaction of a base with an acid, metallic oxides are said to be basic oxides. Metallic oxides means basic oxides. Reaction of a non-metallic oxide. Non-metallic oxide means you can take like carbon dioxide plus NaOH gives rise to Na2CO3 plus H2O. You can take sulfur dioxide plus KOH or NaOH forms Na2SO3 plus H2O. So all these are sulfur dioxide, carbon dioxide, all are acidic in nature, acids you can say. Sodium hydroxide is base, Na2CO3 is salt and H2O is water. You saw the reaction between carbon dioxide and calcium hydroxide lime water in activity 2.5. Calcium hydroxide, which is a base, reacts with carbon dioxide to produce salt and water. Since this is similar to the reaction between a base and acid, we can conclude that non-metallic oxides are acidic in nature. Non-metal oxides are acidic in nature. Metal oxides are basic in nature, but not every time. See, CO, non-metal oxide, neutral. NO, non-metal oxide, neutral. N2O, non-metal oxide, neutral. These three are neutral. You can remember these for your class 11, class 12 entrance examinations and all. CO, NO, N2 are neutral in nature. There are some metal oxides which are amphoteric. We have seen just now zinc oxide, Al2O3 type, beryllium oxide, all these are going to be amphoteric. Meaning of amphoteric is they react with both acids as well as bases. They are metal oxides but amphoteric in nature. And carbon, nitrogen oxides, CO, NO, N2 are non-metal oxides but are neutral in nature. So in general, metal oxides are basic in nature, non-metal oxides are acidic in nature. Yes, you got the point. So we'll see these questions and we'll conclude this class. Why should curd and sour substances not be kept in brass and copper vessels? Brass and copper vessels are metals. Metals means bases. Curd and sour substances are acids. So you can expect there a neutralization reaction. So we should not keep. Common sense point. And this common sense, our grandma, grandpas, they will be having much better than us. Which gas is usually liberated when an acid reacts with a metal? Hydrogen gas. Okay, na? So we'll write an example, illustrate with an example. Is asking for metal. Metal I am taking here, zinc, same. Okay, na? No other example. Very simple. ZnCl2 plus H2. Aluminum also you can take. Sodium also you can take. Potassium you can take. Magnesium you can take. Calcium you can take. How will you test for the presence of this gas? Hydrogen gas. When this gas is sent into soap solution, bubbles will be formed. Those bubbles, when you are keeping a candle, pop, pop, pop sound. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. Effervescence in chemistry means that is carbon dioxide. Better. Simply remember, okay? And the gas evolved extinguishes a burning candle. Yes, carbon dioxide is used in fire extinguishers. Write a balanced chemical equation for the reaction if one of the compounds formed as calcium chloride. If one of the compound formed is calcium chloride means the first compound should be calcium carbonate with hydrochloric acid. You will be getting the CaCl2 plus CO2 plus H2O. Fine. So listen to this class again if you have any doubts. 2.2, 2.3, 2.4, all these are very simple. We'll discuss all those parts in next video. Thank you.